All right, we have a question from someone. Go ahead. Why do we need an empty constructor sometimes? You don't. You don't need to define a constructor. And if there's nothing special that has to happen when you create your object, you don't have to write a constructor at all. And there's always a default one that's provided for you. All right, questions about PA3. In node ingest, if the first line is A, should the flag to indicate whether it is a question or answer be set to true? How after modifying the 20Q text can we rewrite into the same file? Okay, so when you're ingesting, right, you read the first line. If it's you read the first two lines. If the first line was an A, you have an answer node. So set the text field equal to that second line you read. If you're using a flag, set the flag to say this is an answer. Set your yes and no children to null and just return. Okay, if the point you're at in the file is ingesting just an answer, then that's all you ingested. Just return that node. If it's a question, right, then go ahead and call ingest twice to ingest the yes and no subtrees. Okay, so after modifying 20Q, how can we rewrite this into the same file? So let me do this explicitly because it's coming up a few times. There's really sort of four phases to running your program. So step one, open file, read, build tree, close file. Do all of that before you do any playing of the game, okay? You can say hi to the user first and so on, but open the file, read it in with your recursive ingest function, build up the decision tree in memory, close the file. Okay. Step two, play the game. Alright. Hello user, let's play a game. Think of an object, tell me when you're ready. Program reads out the first node. If it's a question mark, wait for an answer. If it's yes or no, travel down to the proper node and so on. Basically play the game till you get to an answer node, right? Tell the user the answer, find out if you were correct or not. So play the game, tell the user your final guess, ask if correct. Okay, third step, which does not always happen, if incorrect, adjust the tree in memory. So if your final answer was wrong, what were you thinking of? What would be a good question I could have asked? Make a new node, put it in place of the tree, right? You're doing all that in memory. Step four, which only happens if, playing the game led to the incorrect result. If incorrect, write file from the tree. Close the file. So when you make a print writer object and you construct it with a file name, right, it creates a new file with that name. If the file already exists, that file is overwritten. Okay. Your file that you started with, you opened, you read in, you built the tree, you closed it, you're done with that file. Okay. So if you play the game and you get the incorrect answer, you adjust your tree in memory. Now you basically recreate a new file with that exact same name, which basically replaces that file. Okay, and you simply write out your tree from memory into that file. That's the node left-right traversal. This is the ingest. So don't think of it as modifying the file. Think of it as rewriting the file, right? Write a new file corresponding to your new tree. And absolutely no way do you want to try to, open that file and move down to the spot where you made the change and then insert some new lines into it and so on. Don't go down that path. It's a path that ends with sorrow. Just you got your tree in memory, create an output file, write it into it by traversing. That's the path that ends with joy and happiness. Does that make sense? Awesomeness. I've been having weird technology issues, either with Zoom. Man, it took me like 6 tries yesterday with my 101 class. With Zoom, I didn't have audio, and then I didn't have video, and then I didn't have anything, and I had feedback and all this, and then this morning I forgot to record the lecture, and yesterday afternoon I tried to record the lecture, but the recording wouldn't close, so I lost all the video, and it's been strange technology-wise. So hopefully this is recording, because there's no recording from this morning's class, so this counts for the B section and the A section. Hopefully it's all there. All right, other questions before we move on to new things. So reminder, your midterm exam is on Friday, so that's not an optional lab day. It's a midterm. It'll be timed. It'll be, I'll be on Zoom, and you'll be doing the exam on Canvas. And I'll give you details once I've actually written it and figured out the details. All right, so let's play with try-catch blocks. And I want to let you know a couple of things about try-catch. All right, so let's write some simple code to blow things up. All right. So this is just a program that generates an arithmetic exception. Okay, division by 0. And let's make it a little more interesting. So let's read from standard in. We'll prompt the user for a number. And we'll say, well, there's another integer available. That was weird. We'll say j equals scanner dot next int, and we'll do k equals I over j. And we'll print out the value of the reciprocal of j, and we'll prompt the user to enter another number. And we'll say goodbye. Alright, it's not a terribly deep program, but I got lots of errors for that. Look at that, 4 errors on one line. That's from like 1 comma. That's pretty impressive. Alright, so it'll ask me for a number. I can put in 5, and that gives me a 0. And, well, that was a pretty silly program. Let's do I equals 1,000. Alright, so 1,000 over 2, 1,000 over 3, 1,000 over 7, right? And if I happen to do 1,000 over 0, I get this exception, okay? And this is not something you ever want your code to produce, okay? If somebody buys code from you and they're doing something and it prints a message like this, they're going to say your code is broken, and they're going to ask for their money back. So since we know that this division might potentially cause an exception, what do? We put it in a try-catch block. Okay, we already know this. So we'll say try. And we'll make a catch block which says if there's an exception E, and we'll say division by 0 not allowed, and we'll set k equal to 0, and we'll go on with life. Alright, so we can compile this, we can run it, 1,000 divided by 2, 1,000 divided by 3, 1,000 divided by 7. If you do 1,000 divided by 0, it just gives us a very nice message, division by 0 not allowed. Okay, so we've done this before. We've used this try-catch structure to catch potential exceptions. So I want to augment this with 2 additional things. One, this catch block is really saying if an exception of this type occurs, go ahead and, do this stuff in the catch block. Okay, so division by 0 generates an exception called java.language.arithmetic exception. I don't think this will work. Hey, that was pretty good. Right? So Java language arithmetic exception occurs typically for integer divide by 0, okay, which is what's going on here. So I could have been very nuanced and said, if you have an exception of type, whatever that was, arithmetic exception, right, then go ahead and execute this. But an arithmetic exception is a runtime exception, which is an exception. Okay, these are extensions. It's another example of class extensions. And when you have a myrect which extends a rect, that myrect technically is a rect, right? It's a rect object with other stuff added to it or replaced. So an arithmetic exception is an exception. So when I have a try catch block that says if you have an exception, right, that will be matched by an arithmetic exception. Let's see, question, how hard is it to get a class you wrote to throw custom exceptions? There's actually a throw statement you can use. And so you can throw exceptions to cause, this kind of behavior. So yeah, the keyword is throw. So if you wanted to be very nuanced, you would look for the particular exception that you're interested in. And this kind of acts like a signature on a method. Okay, so you're executing code in the try block. If an exception of type blah occurs, the system will look for a catch block which expects an argument of type blah. Okay, and you might have 3 different catch blocks: an arithmetic exception, an array index out of bounds exception, and a file exception, right? And if you got an array index out of bounds exception, it would match that block, and it would go ahead and execute the code in that catch statement, that catch block. Okay, so usually, you know, when people write this, they just say catch exception E, because chances are you're only expecting one possible type of thing to go wrong. But if it's possible other things could go wrong, you can have multiple catch blocks. Okay, and the one corresponding to your exception will be the block that fires. The other thing is you can have a finally block. So I have a finally block that just says I'm done dividing. The danger is past. And if your code succeeds in executing all the statements in the try block, the catch block is ignored, you come down and execute the finally block. If something happens in the try block and you get an exception, you come down and you execute the statements in the appropriate catch block, and then again you execute the finally block. Okay, so this is easy to demonstrate. So I divide 1,000 by 2, tells me it's done dividing, and I get an answer of 500. I divide 1,000 by 7, tells me it's done dividing, and I get my answer. If I divide 1,000 by 0, I get my nice error message from my code saying division by 0 not allowed, and then it tells me it's done dividing. Okay, what's the advantage of this over just putting this statement after the try-catch block? Here's the really weird thing that you'll either love or perhaps hate. Let's put a return in the division by 0 catch block. So if you try to divide by 0, we'll say division not allowed. We won't bother setting k, we'll just return. Okay, we'll just give up on the user. So divide by 2 works the same, divide by 7 works the same. Divide by 0, I get my error message, and then it said done dividing, and then it returned. This should look weird to you. I tried to divide, I got an exception, I came to my catch block, it said division by 0 not allowed. It did not return. Instead of doing this return, it came down here and did my finally block and said done dividing, and then it came back here and it did my return. Okay, to me that's a little goofy, because, you know, if I look at this code, when I say print this out and then I say return, I kind of assume it's going to return after this. But no, before it leaves the catch block, it will look for a finally block and it'll do whatever is in there. And then if I said to return from the catch block, it'll go ahead and do the return. I've never used that in my life, okay? I've never done this other than when I'm teaching this. I can see where it could be useful, right? Because you can basically put cleanup stuff in your finally block and, you know, have a bunch of catch blocks, and each of them can just say return, but they can all be assured they'll process the finally block before actually returning to the caller. But, you know, it's a little weird to me. But anyway, that's the two other things I wanted to add to try catch blocks. One, you can have multiple catch statements, which will be matched based on the type of the exception. And two, this idea of a finally block, which is always guaranteed to be run if you go into your catch statement, even if you say return. All right, questions on that? All right, so let's try catch. So I was going to talk about arrays, and I was going to talk about packages, and I was going to go into some details of stuff, and that's all good stuff, but it's not terribly exciting. And we should do exciting stuff in here. So let's play with some graphics. Let's do some GUI stuff. So we're going to play with this class called swing. Okay, it's a package of classes. We'll talk about packages one of these days soon also. But Swing is a package, contains a number of classes. One of the classes is a Jframe. We played with this briefly week 1. Another class is a JPanel. Another one is a JButton. Another one is a Jtextfield. And these are all visual elements, okay? The basic idea is a Jframe is this window that we can make. It has like a title bar, it has a little picture of a coffee cup or something in the corner. It's got the stuff in the upper right corner for you know, closing and maximizing, minimizing, and rolling down and rolling up. And you know, there's some kind of border decoration sometimes, and there's a background color, and you can grab a corner and grow and shrink, and so on and so forth. Okay, that's a Jframe. A J button is, you know, a little clickable button. A text field is a rectangle that has some words in it. And we can place these things inside our Jframe. So when we move the frame around, these things move around with it. But usually, what we do is inside our Jframe, we place a JPanel. Why? Because a panel is really a container for other widgets, other objects. And then inside that JPanel, we can place the button and the text field and so on. So we can cobble together user interfaces by just creating objects of these types and using a few commands. Okay, so the Jframe method, for example, can be constructed by just saying Jframe with no arguments, right? That's pretty straightforward. And there's an add method. Okay, so Jframe, this is where extensions come in. A Jframe is a frame, which is a window, which is a container, which is a component, which is an object, right? Everything that's in an object is automatically in a component, and a component probably has extra stuff added. And everything that's in the component or in the underlying object is in the container. So by the time you get to a Jframe, you have a whole bunch of stuff. You have this whole toolkit of methods and fields available to you, some of which was created as part of the Jframe class, some which was inherited from these other classes. And so the methods available in a Jframe are relatively few, but from the frame you inherit all of these methods, and from the window you inherit all of these, and from the container all of these, and from the component all of these, and from the object these. So all of these are methods that are available inside a Jframe, okay, including the add method. And we can add any kind of component, and it says appends a specified component to the end of this container, whatever that means. Okay, JPanels, so Jframes are Jframes are frames, which are windows, which are containers. JPanels are just components, which are containers. Okay. And what's the one sentence punchline? JPanel is a generic lightweight container. And you can read tutorials on how to use it. We're not going to worry about that. Okay, JButton is an abstract button, which is a component, which is a container, which is a component, which is an object. Right? Text field is a JText component, which is a J component, which is a container, which is a component, which is an object. So you're getting the idea. Everything is an object. Most of these visual things are components extended into containers, and then from there it might branch off into one thing or another. A Jtextfield is a component that allows editing a single line of text. A JButton is a push button. Okay, so these are basic building blocks. What I want to do right now is just sort of show you how easy it is to use these things with just a few lines of code. Now, probably Thursday we'll start digging around with Eclipse. Okay, in Eclipse we're going to have different ways to work with these elements. We're going to have a drag and drop interface called Window Builder, and most IDEs have some kind of drag and drop way to make graphical interfaces. Eclipse Window Builder is a pretty straightforward one. And so the code that we're writing today is lower level than we're going to have to do when we're getting to PA4. Okay, we'll mostly drag and drop. But I want you to see what's going on underneath. And I want you to understand that the tools we're going to be using, like Window Builder, or if you use NetBeans or IntelliJ, they're really just wrappers around systems that create this code for you. Okay, but you can always go down and you can just bare hand this code. And it's a good thing to be able to do sometimes. All right, so let's see. We are sitting here. Let's make I call it cool. I'm going to make a class called myGUI. And it's going to have a constructor, creates a new myGUI. I better be consistent about case. Alright, and that's all that my cool class is going to do. It's just a main program. It's just going to create a myGUI. And there's a myGUI class. Alright, so what is a myGUI going to do? Well, it's going to make a Jframe. So let me suppose that there is a method in myGUI called doStuff. I'm going to call that method to make my GUI do stuff. Alright, so what are we going to do? We're going to create a Jframe. So I'm going to make some class variables in here. I'm going to make a Jframe called frame, and in here I'm just going to create a new Jframe. And we did this week one, we did this the first or second class, right? If we just create a frame, it's going to look really small. So I'm going to set the size of it to be, let's go 700 by 500. So that's width and height in pixels. And I'm going to set it to be true. Set visible to be true. Right? Now Jframe, if I look for set size, that's a method inherited from window. Right? And set size, I can specify a dimension, which is a class that has two components, width and height, or I can specify two integers, width and height, right? And it'll set the sizes of the window accordingly. And set visible is also in window, and it takes a Boolean and it shows or hides the window depending on the value of that Boolean. So this will make it 700 wide, 500 tall. This will make it visible. So let's compile cool. Notice when I compile cool, it's trying to compile myGUI because it knows it needs a class myGUI, and there is no myGUI.class in here. Okay, it's complaining cannot find the symbol Jframe. Why is that? Because Jframe is imported from java.swing, javax.swing.jframe. So let's import that. Oh. And let's see if that compiles. That does. Let's run it. Right, and there's our frame. So we can move it around, we can make it hide, we can bring it back, we can maximize, we can demaximize, we can resize. And we can exit out, but our window doesn't close when our code doesn't stop when we exit out. Right? On the other hand, in my code, if I Control-C this, right, my window will disappear. So there's this trick we can do in here. After we construct a frame, we can tell it what to do when we close the window. So we can say set default close operation. Right, and there's a set default close operation. And we can say do nothing, hide, dispose, or exit on close. Okay, and these are things defined inside different classes. So inside the Jframe, there is a field called exit on close. Right, it's a static field defined inside the Jframe. So I can say set default close operation jframe.exit on close. And I'm accessing it statically, right, with the name of the class. And that's an integer value, which says when the frame closes, the program should exit. So now I've got my frame. If I close that window out, my code exits and I come back to a prompt. Okay, let's make a JPanel. And let's add it to the frame. And you gotta trust me on this that there's a reason for doing this. So let's make a button. Well, let me make some more variables up here. And I probably don't need these to be class variables, but I'm going to do this anyway. I'll call this button clicker. And I'll say clicker equals new JButton. And then I'm going to say in my panel, let's add the clicker. All right, so we got a JFrame, we made it visible and so on. We created a panel, added the panel to the JFrame, and then made a button and added that to the panel. Oh yeah, I need more imports. All right, so I also need java.awt. That's the abstract windowing tool. Okay, Swing is built on top of that. AWT is a low-level package that it includes stuff that you need to build up other things. Ooh, still didn't like it. Oh, let's do this. Let's just pull in everything. You could be tactical about it. You can pull in a J button and a J frame and all that kind of stuff, but we'll just grab everything. All right, go ahead and run this. There's our window. There's something right there. It's a tiny little button. When I point at it, it changes the border, and when I click it, it changes its appearance. Okay, not terribly exciting, but possibly. All right, so we got a button in there. So on the Jframe, the constructors for Jframe, right, we can construct with no arguments. We can also construct with a title string, right? And if we do this, creates a new initially invisible frame with a specified title. So I can say Jframe equals new Jframe. and I can say this is my Jframe. So now I've got a title. So this is my Jframe. Okay, the J button, when you construct, you can also construct with no arguments, but you can also specify with an icon, right? Or with a string of text, or with both text and an icon. What's an icon? I don't know. Click through, take a look at the icon class, right? And you'll see ways to construct this. Well, it's, yeah. It extends other things, but you can basically take an icon from a file, or you can run some code to generate an icon, and then that icon can be used in a button. Okay, so let's just construct a button with a string of text. So let's make a new button. And we'll say click here for things to happen. Right? So now I got a button that says click here for things to happen. Of course nothing happens, but it could. Alright, so we're just putting these pieces together. Let me avoid a potential problem down the road. We really don't want to make this thing visible until we've added all of this stuff. Because sometimes you'll make it visible and then you'll add more components to it and you won't actually see those until you move the frame. So the last thing we'll do is make it visible. Alright, so we've got a button. Let's add a text field. So let's make a Jtextfield called text. We'll construct it down here, and then we'll add it to our panel. Alright, well, that little tiny rectangle right there, that's our text field. We didn't really give it a size, but we could have. So we could make it 100 by 50. But only if we spell it right. Oh, that didn't work. Never mind. Ignore that. Yeah, that's more complex than it should be. But let's do this instead. Let's construct our text field with some initial text. Right, so now our text field has initial text inside, and it's an editing field, right? We can delete stuff and type stuff and select stuff and so on, right? But nothing is happening. There's no action taking place yet. We just have these widgets that we can click or we can type into and so on. So let's put some action on here. Okay, so the thing we want is an action listener. Okay, action listener is what's called an interface. We'll talk about interfaces more another time, but basically it's a way to interact with events. Okay, everything we do with GUIs is going to be event driven. So think flashing LEDs and interrupts in Engineering 270. If you've done 270, it's event-driven programming. Okay, if you've done anything in Scratch, if you've played around with Arduinos and stuff, this is the direction we're going. So an action listener is a thing that basically implements one method called action performed. Okay, and action performed takes an object of type action event, right? And we can do various things with that. So how do we do all of this? Three really easy steps. First of all, when we make our class, we have to put in a keyword, implements, and say this implements an action listener. Okay, so we got to have that, implements action listener. Saying that it implements action listener means that we have to create a method called action performed. And it's got to be public, it's got to return void. It's got to be called action performed, and it has to take an argument of type action event. And it could be, you know, any argument that we want. It doesn't have to be E, but it's usually E. And let's just put a print message in there saying we're inside action performed. Just so we know. We're going to need to import java awt.event. Okay, and then there's one more thing we have to do. We want this action to happen when the button is clicked. So we create a button. We're going to say clicker.add action listener. And what are we going to specify here? We're going to specify an object that contains an action listener. Well, this is the object that contains an action listener. It's this method right down here. Okay, so what object do we want to specify for the action listener? It's really me, okay? And the keyword for me or I is this. This is the ego of an object. This, THIS, means me, okay? So when we say GUI.doStuff, we're running the doStuff method inside this object called GUI. The doStuff method, right, comes down here. When it gets to this means GUI, the object GUI. Okay, and GUI is an object of type myGUI, and myGUI has already said it implements an action listener, and inside myGUI is a method called action performed that takes an argument of type action event. So this statement up here where we say clicker add action listener, this is tying this method into the action of clicking on this button. Okay, that's a lot of parts and pieces and a lot of words and crossed over arrows, but it's really just these three steps, right? Step 3, say which object has the action listener. So let's compile this, let's run it, and when I click my button, I get a message coming out of my code saying I'm inside action performed. And every time I click this, it tells me, hey, something just happened. Alright, so we're connecting actions with this GUI to things happening inside our code. Well, once you can do that, you can do anything. Okay? After that, it's all just code. So let's make an integer click count. And let's increment click count, append it to this inside action performed message, and let's keep track of how many times we've clicked our button. So I click this, it says count equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe after 10 clicks I want to exit, so if click count equals 10, I'll just call system.exit. Got to compile it. Click it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it exits. Alright, we have a text field we haven't used yet. has a set text method which will let us specify what the text of that should be. Let's just set it equal to click count, and we'll append an empty string to it to turn it into a string, and we'll pass that to the set text method. So now every time I click, my text field over here shows me my current click count. And it goes up to 9, and then one more click and I exit. Alright, so we're tying these things together now. Alright, we're making typos. Now we have actions coming in. We have things that we're changing on the outside. This E that's passed to the action listener, by the way, let's just print that out, right, in our message and see what it looks like. It's all of this stuff, right? So count is equal to 1, E was equal to, well, this is what kind of thing it is. It's an action performed. Here's the text on the thing that was clicked. Click here to for things to happen. Here's when it was clicked, so every time I click, that when increments. Here's the modifiers. I'm clicking with my left button, that's button 1. If I hold down shift and click, it tells me modifiers equals shift plus button. If I hold down control and click, it tells me modifiers equals control plus button 1. If I hold control and shift and I click, it'll tell me I had a control and a shift and a button 1. And this is the 2-string version of E, right? Remember, E is an action event, but it has all of these different aspects to it that we can get a hold of, right? We can see what the action was that was performed. That's an integer, right? We can look for masks if the control button was pressed, or the shift button, or the meta button, and so on and so forth. And this is just looking at E turned into a string using its 2-string method. Okay, but all this information is available to us. And so in our code, we could tap into aspects of E, call different fields from it, and find out more information about the event that occurred. So that's a really sort of very fast, high-level overview, but really the goal here is just to sort of compel you that it's really straightforward. I mean, we have 44 lines of code here. We've got a frame, we've got buttons, we've got text fields, we've got everything interacting with everything, all under a few lines of Java code, right? You want to exit after 10 clicks, it's as easy as this. You want to display the number of clicks in the text box, it's as easy as that. We can respond to people typing in the text box. We can respond to clicks outside of the button, and so on. So we'll play with Eclipse towards the end of the week. We'll play more with this tomorrow. And then once we get an Eclipse, we'll really jump in and start seeing all the different widgets and the ways we can interact with them and so on. So it starts to get really fun from here on out, okay, in my opinion. This is where we sort of take everything that we've learned, all the hard work, and you start using it just to start making things and doing things you want. So so this is the good part of the course and the curriculum. All right, have a great rest of the day. I will see you tomorrow.